Assalamu alaikum wa rahmatullah. So, in this video, let me discuss the problem. The problem is based on the theory of collisions. Okay, let me just address here the problem. If it is suppose, given that we have the particle, okay, and particle is at a height of, let us assume this is my plate here, okay, that is going to be aligned horizontally, and there is some particle that the particle is at a height of 3 meters, okay, relative to this, what I can say, the surface of this plate. There exists in the height of those edges here, or maybe 3 meters, okay, and the particle, it starts from rest and it's allowed to fall under gravity here, okay, and it just makes a collision with this, what I can say, the plate, okay. After making some collision, it attains a height of, let it be here, h1, okay, and the particle is allowed to come back along the same path, and it attains another collision, okay, it attains another height after the second collision, okay, and this process is going to be repeated, but the height attained by the particle in each successive collision is going to be lesser, okay, means then that in this, at the third collision, particle will attain a height of h3 and so on, okay, and ultimately my particle stops here. If I will suppose here the distance covered by the particle before it comes to rest is x here. If I want to calculate this x here, okay, but it's given also in a problem, the coefficient of restitution is here 0.5, okay. What I need to calculate? I need to calculate what will be the distance that will be covered by the particle before it come to rest, okay. So how I can approach the problem of this type? In order to look to the solution of this problem, I will just use the definition of the coefficient of restitution, okay. As we know, the coefficient of restitution, it is defined as relative velocity of separation, okay, to the relative velocity of approach, okay, in a given collision. When we talk about the type of collision and we define the ratio, indeed this is a very important ratio, and it's defined as the relative velocity of separation to the relative velocity of approach in a given type of collision and all that, okay, as if it is given in a problem that we have the value of restitution as 0.5 units, okay. How I can and just try to visualize my solution of this problem. Okay, for that what I will do, I will just make one thing here. Look, the particle, it initially starts from rest, okay, before it can collide with this plate, it will achieve some velocity, okay, and the particle will have a different velocity after the collision, okay. Now when it comes back after the first collision along the path h1, it just collides again with this plate and it attains a height s2, okay, it just comes back along in the same fashion as that of in the collision first, okay, after attaining a height h1, and it just makes the second collision and it attains a height of h3 after third collision, okay, but in each successive collision the particle attains some height, it is going to be less than earlier one, okay, and as a result what will happen, particle will make some number of collisions with the plate and ultimately it stops. Before particle can stop, how much that stopping distance, how much a distance that it will cover before it can stop, how much that will be, I just notified that when x, and this is something that I will just calculate here. For that, the coefficient of restitution in a given question is given, okay, like 0.5, but I will use here the definition of coefficient of restitution here. Look, let us assume that after the first collision, the velocity attained by the particle, it will be, suppose, v1, okay, it will be v1, and before it can collide, it will achieve some velocity here due to the gravity field here, and let it be u, okay, so it will be here, yes, my e, okay, means that my e will be simply here, v1 will be here, yes, because plate is at rest in each collision, so it will don't have the velocity here. It's only the particle that has the velocity in every collision. So in the first collision, the particle velocity is v1, but before it can collide with the wall, its velocity is u, okay? But the particle starts from rest, okay? I will use as an equation that v square minus u square will be 2gh, okay? As the particle starts from rest, it will have the velocity here, yes? And this fellow will go out simply here, v square will be 2gh, okay? Means that my particle velocity will be simply 2gh. I will use here this equation in every collision, okay? Means that my v1 will be after the collision, my particle velocity will be here, yes, 2gh1, okay? Hope you are getting it, because when the particle it just make the collision with it, finally it stops here. Anyway, this equation will be valid here in every collision, okay? So on the same behalf, my u, it will be simply here, yes, 2g capital H, okay? Because particle initially is at a height of h. Meteor is that's indeed given, no problem. But let me mention it first of all here. So if I will calculate my h1 here, yes, so this will go with this. My h1 will be simply, yes, it will be e square of h, okay? This is my equation first here. Not only this, when we talk about S2 here, okay, my S2 will be here, yes. Again, my E will be here, yes. Particle velocity after the collision, it will be here V2 but V1, okay. I am going to follow this kind of, the sequence here in order to, get exactly my value of X. It is something that's self-understood right now here, okay. It is based on the previous step, but my V2, it will be here, yes, it will be E times V1, okay. My V2 will be E times V1, but my V2 will be here simply, yes, it will be here again under root of 2gh S2 or under root of 2gh1, means that my S2 will be here E square h1, that will be, but h1 is here, yes, it will be E4 of times h, okay. And accordingly my h3 will be here, yes, it will be E square S2, that will be E6 h, and so on, okay. So what kind of, the pattern I will get here, yes. So my x will be here simply, yes, my x will be here, it will be h plus h1 plus s2 plus h3 plus so on. But here we need to be very careful in a way. Look, when the particle it just collides here, it attains a height of h1, but the particle it just comes back along the same height in order to make the second collision here. Means that it will cover a distance of s2 in the first collision, 2 times h1 in the first collision, also 2 times s2 in the second collision, and 2 times h3 in the second collision, okay. So it will follow this kind of trend here, and I will get, in this kind of series here, okay. So if I will just give the values back to the, these h1, s2 and h3, what I will get here, my x will be simply here, it will be h, yes, 2 times h1 will be here, it will be e square h, okay, it will be 2e4h plus 2e6h plus so on. So here it will be, yes, I will just make here h common, so it will be 1 plus 2 e square will be here, 2 e square is everywhere present, so it will be 1 plus e square plus, yes, e4 plus so on. So here it will be h, yes, 1 plus 2 e square. Look, when we talk about this kind of series, it's my, what I can say, the geometric series here, okay. Why so? Because if I will just make the ratio of the successive number of terms here, just like e square by 1, it will be e4 by e square, it will be e6 by e4, and it will be e square here, okay. Means the ratio of the successive number of terms for this series is going to be same, so it's a geometric series here, and it is some can be written as, yes, a divided by 1 minus r. Okay, provided that the r is here, my r, it should be less than a. Okay, what's the value of r here? That's e square. My r, common ratio for this geometric series, it is r, that's e square. Okay, e square is here 0.5 square, that will be 0.25. okay, that's less than 1 here. Okay, for a given geometric series, if the common ratio is less than the first term, so its sum will be written as like this way. Okay, so for this, what I will get here, yes, it will be h here 1 plus 2 e square. Yes, a is simply here 1 and it will be 1 minus e square. Okay, so it will be h here, it will be 1 minus e square plus 2 e square 1 minus e square. Okay, so it will be simply h into, it will be 1 plus e square or upon 1 minus e square. So my x will be here, yes, h is given as 3 and it will be 1 plus, yes, 0.25, 1 minus 0.25. Okay, after solving it further, what I will get here, yes, it will be 1.25 here, it will be 0.75. Okay, this will go with this, it will be 25 3s are, it will be 25 5s are. Okay, and this 3 will go with this. Simply my x will be here, yes, my x will be here 5 meters. Okay, the particle will cover a distance of 5 meters before it can stop. Okay, so this was all about this problem. This way my problem ends here. Thank you.